Hey everyone, today we are going to talk about of the laboratory practice of on dead curves by Alexis Valdivieso and Ronan Ana Salvas. Okay. The first part is introduction. Okay. The laboratory practice on dead curves is essential in various fields such as microbiology, toxicology, and ecology. It studies how different agents such as bacteria, viruses, and chemicals affects the viability of living organisms over time. This research allows us to better understand the effectiveness of disinfectants, the toxicity of chemicals, or even survival capacity of species in the hostile environment. By analyzing these curves, is crucial data is obtained for risk assessment and the formulation of strategies for the control and prevention of diseases, pollution, and of other environmental hazards. Okay. The principal objectives for this investigation is to investigate the resistance of bacterial species to adverse conditions such as high concentration of the toxin substance to better understand their ability to survive in contaminated environments. They analyze the effectivity of environmental control strategies and reducing microbiological population. This contributed to the prevention of diseases and the migration of the risk to public health and the environment. And finally, establish relationships better between the concentration of a chemical or physical agent and response of living organisms, providing crucial data for the formulation of policies and environmental management measures. Okay, now explain the materials and surplus. Okay, uh, the principal materials for the microbiologic is the microbiologic stain of interest, Escherichia coli, Listeria monocytogenes, and Salmonella. Test tubes with culture, sustainability, soil, culture, medium, agar, MRS, agar, XLD agar, and Petri dishes. Pipetters and tips, pipettor, test tubes, 50 millimeters, and buying marine over laboratory oven. Okay. And the next part is the methods. The methods to this laboratory is the first part is the preparation of microbiological cultures. The first part is prepared to inculate the microbiological stain of interest into the test of Erlenmeyer's flash containing the proprietary liquid culture medium. B, they incubate the culture at the optimal temperature for 24 hours to allow the adaptation of the microorganisms to the culture medium. And the next part is microbiological inactivation treatment. Uh, okay, use a gloves, lab coat, and mask. Expose a liquids of the microbiological culture to different temperatures, 16, 17, 18 grade centigrade, and times 1 to 3 to 10 minutes in the water bath or laboratory oven. and check the points in the top. The next part is the graphic and analysis of microbiological death curves. And okay, in this part, they plot the logarithm of microbiological survival log CFO, the as a function of the time for the temperature test. Identify the negative slope of the microbiological death curve in the linear profits for the age temperature. And finally, calculation of D and zeta values. Calculate the D value for the age temperature using an equation of D. The next part is plot the logarithm of the D value as a function of the temperature. Calculate the letter zeta from the slope of the line obtained using the equation of z -1 slope. Okay, the next part of this experiment is the explain the results.
Okay. Results obtained in experiment time. When the STAR experiment was carried out, the following results were found. For the first dilution, we have nine, nine colony forming units. And for the second dissolution, we have three CFU. For the third, we have 12. For the next six, for the fifth, we have 18. For the sixth, we have three CPUs. And for the last, we have 0. To explain the graphics, we can explain these results with the graphics. Well, it is observed that microbial growth at 65 degrees Celsius and after having been diluted has a downward trend. Even so, there are maximum and minimum peaks. In the formation of colonies forming units, CFUs, that drops dramatically after dilutions tend elevated to -5 until reaching total inactivation that is 0 CPUs. In tend elevated to -7. However, these peaks in the results could have been influenced by human errors or other external factors. The value of D in this case is the 1.33, and zeta for doing all the practice at temperature of 65 degrees. We take this temperature that like the value of zeta. I said, we have the results. It's a normally results because maybe we have some errors or maybe problems with the culture medium. And now that we have the results and the inactivation is completed. Annexes.
Okay, for this part, answer the question of the annexes. What is the importance of killing curves, the value and zeta value in the food microbiology? Okay, the killing curves of the value are fundamental of food in microbiology. These parameters provide crucial for information of offenses of head treatment process in elimination the pathogenic, the spoiling microbiological in foods. The D value represents the time required to reduce the microbiological population by a decimal logarithm and specific temperatures, while the zeta value indicates the temperature change necessary to alter the reduction by the time by factor of 10. This data allow establishing control, processing, conservation, and guarantee food security. These parameters is the D to 1.1 to 33 and zeta the 65. Okay, the next question is, what is the factors can include the effectivities of microbiological inactivation treatment? Okay, these factors affect the experiment, the temperature. The treatment temperature can affect the rate in activation of microbiologists, with higher temperatures generally being more effective process. And they expose the time during with microbiologic and expose the treatment effectiveness that inactivation. Another factor is a concentration of the antimicrobiological agent. Is the case the chemical treatment, the concentration of the microbiological agent can influence in the ability to inactivate microorganisms. The pH, the medium can affect the effectiveness of certain treatments, since some microorganisms are more sensitive to change the pH than others, and more. What is necessary to perform cereal dilution and plating in prairie dishes to measure microbiological survival? Okay, the perform cereal dilutions can plating in prairie dishes is necessary to measure microbiological surface because it allows for the estimation of the value microbiological compounds in the sample. Cereal dilutions help to reduce the microbial population to manageable level where individual colonies can be continued accordingly. Okay, now Alexis.
Okay. How are D and zeta values related to pasteurization and sterilization processes in food preservation? Well, they allow determining the optimal time and temperature for an effective heat treatment, considering the resistance of microorganisms present in the food and the desired conservation objectives, pasteurization and sterilization. They help optimize thermal processes and guarantee the microbial safety of thermally processed foods, preventing outbreaks of foodborne illnesses. Next question. What other methods can be used to estimate microbial inactivation and calculate D and zeta? Well, apart from the traditional techniques, there are other more modern techniques to estimate microbial inactivation and calculate the and zeta values. Kinetic models, molecular analysis techniques, expert systems and prediction software, methods based on bioimpedance, emerging thermal methods, and that's all.
Thank you, teacher. This is my presentation.
Thanks.